The previous knowledge for today class is element and electronic configuration. Right? Can someone tells me what element is and examples of elements? Therefore we can say element is the simplest form of pure substance which cannot be broken down by ordinary chemical or physical means. Also, example of elements are chlorine, bromine, iodine. I hope you know how to write electronic configuration using SPDF, right? Good. Behavioral objectives are 1. State the periodic law. 2. State the periodic properties of elements. 3. Define groups and periods. 4. Place elements into different groups, periods, and blocks. 5. State the name of groups in the periodic table. 6. Lists the properties/trends on periodic table. 7. Explain the diagonal relationship between period 2 and 3. Dmitry was a Russian scientist who constructed a periodic table. He arranged the elements in order of increasing relative atomic mass, RAM. He also pointed out that elements with similar properties kept recurring at irregular intervals or periods. He predicted that there were undiscovered elements which could fill those gaps in his table, and he even predicted the possible properties of these elements. Later, after his works, elements such as scandium, gallium, germanium etc. were discovered and fit into his tables, and properties too were confirmed. The elements known as far is about 118. Hydrogen is the most abundant element in the universal. Oxygen, a non-metal, is the most abundant element in the earth crust. Aluminum is the most abundant metal in the earth crust. The table helps us to correlate the properties of the elements and thus remember their chemistry. With the discovery of the electronic structure of the atoms, it became clear that elements do vary regularly with their atomic number. The modern periodic law states that the properties of the elements are a periodic function of their atomic number. With this modern technology, it becomes clear that the electrons and their arrangement in the atom of an element that are responsible for many of the properties of the element. Periodic properties is any properties of an element which changes regularly with increasing atomic number. Orbit and orbital. An orbit is a well-defined circular path around a nucleus in which electrons revolve. The maximum number of electrons in any orbit is given by 2n2, where n is the number of the orbit. Examples are KLMN shells. K shell, its energy level is n equals 1, that is, it falls under orbital of s. S orbital maximum of electrons is 2. L shell, its energy level is n equals 2, and it falls under s and p orbitals. Its max number of electrons equals 8. M shell, its energy level is n equals 3, and it fall under s, p, and d orbitals. Its mass number of electrons is equals 18. N shell, its energy level is n equals 4, and it falls under s, p, d, and f orbitals. Its max number of electron equals 32. Orbital is the region or sphere where high percentage of electrons are maxima or found. Or, it is a three-dimensional space around a nucleus within which the probability of finding an electrons is maximum. The maximum number of electrons present in any orbital is 2. The number of orbitals in main energy level equals n2, where n is the energy level. Groups. Families of elements with similar chemical properties that lie in the same vertical column on the periodic table are called groups. Groups are often referred to by the number over the column. Many of the groups have special names, see figure 3.8. 4. Example, the first column of elements, group 1, has the name alkali metals. The group 2 elements are called the alkaline earth metals, the group 7 elements are the halogens, and the elements in group 8 are called the noble gases. We use valence electrons to determine the groups of an element. Periods. The periods are horizontal rows and numbered from 1 to 7. Elements in the same period have the same number of electron shells, that is K for period 1 or n equals 1, L shells for period 2 or n equals 2, etc. and so on. Note, the number of valence electrons of the elements in the same period increases progressively by 1 across the period from left to right. Among the elements in periods 6 and 7 are the elements of lanthanide and actinide series, known as the inner transition elements. Note group 1 and 2 belongs to S block, while group 3 to 7 and 0 belong to P block. 21 to 30 D block. Lanthanide and actinide belong to F block. Diagonal relationship. It is a relationship between period 2 and 3 where the element in period 2 diagonally shares similar properties with element in period 3. For example, lithium resemble magnesium due to the reason of pairs of elements having almost identical ionic radii and polarizing power.